Hi students, today we are going to start a new chapter circles, right? Last year itself you have studied the chapter circles, right? We have studied so many properties. Now we are going to study a new properties based on circles, right? Here we are going to discuss only three things. That is nothing but tangent to a circle, secant of a circle, point of contact, right? Tangent to a circle, secant of a circle, point of contact, right? So only we are going to know what is mean by point of contact, right? Only we are going to know, we are going to discuss what is mean by point of contact, what is mean by secant of a circle, and what is mean by tangent to a circle. But in this chapter we are going to discuss, right, we are going to discuss only the tangent to a circle alone, right? Based on the tangent to a circle, right, based on the tangent to a circle, we are having some properties. By using the property we will find, right, we will find some values like a radius of a circle or a tangent, right, tangent, length of the tangent of a circle, right, length of the tangent, or chord, right, chord, or finding the area of a circle, perimeter of circle. For finding the area of circle, perimeter of circle, what we are needed, we need the radius, but they won't give the radius. With the help of the properties of tangent to a circle, we are going to find the radius. So before that, you want to know what is mean by tangent to a circle and point of contact and secant of a circle, right? So see, in this chapter we are going to discuss only based on the tangent to a circle, only for our information, right? Only we want to know what is mean by tangent to a circle, what is mean by secant of a circle, and what is mean by point of contact. So for that alone now we are discussing, right? Okay, in a circle, right, I'm just drawing the circle. In a circle we are having a infinite number of points on the circle, right? Infinite number of points. There are so many points on the circle, circumference of a circle. We are having infinite number of points, right? Infinite number of points, right? And there are infinite number of points on the line also, right? An infinite number of points on the line also, right? Infinite number of points on the circle also, right? Circumference of the circle, there are infinite number of points. At the same time, there are infinite number of lines also in the line, right? Infinite number of points on the line, right? Infinite number of points, right? When a line meets a circle, a line, right, a line AB meets a circle at only in one point, that meets a circle at only in one point, is called a tangent to a circle, right? See, we are having infinite number of points. A line meets a circle in only one point, right? Only in one point is called a tangent to a circle, right? Tangent to a circle. Understood? A line touches or meets a circle in only one point, and that line is called as a tangent to a circle. Tangent to a circle. And the point, right, the point, there is a point, contact between a circle and the line, right? And this point is nothing but point of contact, right? A point where what is it, a contact between the circle and the line is nothing but point of contact. Point of contact, right? Next, if a line intersects a circle, right, if a line intersects a circle at two different point, right, two different point, here this is the circle and the point, right, A, you can give name C and D, right? The point C and D are the two different point. A line, right, a line L intersects a circle at two different point is called as a secant of a circle. Secant of a circle. I told you that in this chapter we are going to discuss only the tangent to a circle. For what purpose we are discussing? What is mean by tangent to a circle? What is mean by secant to a circle? We want to differentiate. Tangent is nothing but, tangent to a circle is nothing but touches or meets a circle with only one point, that is called a tangent to a circle. And secant is nothing but intersect with two different point, intersect with two different point, that is called a secant of a circle, right? Point of contact is nothing but contact between the circle and the line, right? The point, right, the point at which the line touches the circle is called as a point of contact, right? So first write down the notes. So write down your notes. See, the notes are very important. Write down your notes, right? A line meeting a circle, right? A line meeting a circle only in one point, that is very important. Only in one point is called a tangent to the circle. A line which intersects a circle at two distinct point, right? Two distinct point is called a secant of a circle. Is called a secant of a circle. Next one is something by the point at which the line touches the circle is called a point of contact. Right? Point of a contact. I told you already in the chapter fully we are going to discuss only the tangent to a circle, right? Now we are going to see the number of tangents to a circle, right? Number of tangents. How many tangents are possible for a circle? We will discuss. Number of tangents to a circle, right? Number of tangents to a circle, right? First one, a point lies inside the circle, right? I'm just taking the point P. A point lies inside the circle. Is it possible to draw the tangent? No, we can't draw, right? So no tangents. If a point lies inside the circle, then we can't draw the tangent. That means number of tangent when the point lies inside the circle, no tangents. Understood? Okay. If your point lies on the circle, if your point lies, the point P lies on the circle, then how many tangents can draw? Only one. That is, a point lies on the circle, only one tangent is possible. Only one tangent, right? If your point, right? If your point P lies outside the circle, this circle, outside the circle, right? From the point, right? From the point, how many tangents are possible? Right? From the point, how many tangents are possible? Two tangents, right? See, I'm just marking the name, and this is the point of contact A, and this is the B. PA and PB are the two tangents, right? P is nothing but external point outside the point, right? External point outside the circle, right? P is the external point outside the circle. So from the point, how many tangents are possible? Only two alone, right? Two tangents alone possible. They are PA and PB. Understood? So only you have to keep it in your mind. They will ask you in 1 marks also, right? So when a point lies inside the circle, no tangents. When a point lies on the circle, only one tangent. When a point lies outside the circle, only two tangents, right? Two tangents alone, right? Next, we are going to discuss properties of tangents, right? Properties of tangent. This is very important, right? We are going to discuss only the two properties alone, right? With the help of these properties alone, we are going to find or we are going to prove, right? So, properties of tangents, right? The first property, a tangent at any point. A tangent at any point of a circle is perpendicular to the radius. That is very important. Perpendicular to the radius. Here OP is nothing but point of contact and the line is nothing but tangent. Here OP is nothing but what is it? Radius, right? So OP is perpendicular to the tangent, right? The radius OP is perpendicular to the tangent. Yes, see that perpendicular to the radius through the point of contact. Understood? Understood, ma? So this is nothing but what is it? I'm just giving the name, right? So AB is nothing but line AB is nothing but the line AB is nothing but tangent, right? And P is nothing but point of contact. Here OP is nothing but radius, right? OP is the radius. That radius is perpendicular to the tangent. Radius is perpendicular to the tangent always, right? I will give you so many example. See, if you are drawing the tangents, right? I'm just drawing the tangents. Sorry, actually. See, I'm just drawing so many tangents, right? And this is the one tangent. Here, this is the point of contact P. I'm just drawing this one. I'm just drawing one more tangent Q, right? I'm just drawing that here also one tangent, right? I'm just giving the name R, right? Point of contact is in the R, right? I have drawn three tangents, right? I have drawn three tangents. What I am saying, see here OP, right? OP is a tangent. See, OP is a radius. OP is nothing but perpendicular to this tangent, right? Suppose this is a tangent, right? And OQ is the radius. OQ is the radius, and OQ radius is nothing but perpendicular to this tangent, right? Here OR is nothing but radius, right? And this is nothing but tangent because the line touches the circle at only one point R alone, right? So this line is nothing but tangent, right? This line is nothing but tangent. OR is radius. So radius OR is perpendicular to this tangent. Understood? So whenever we are having a circle and we are having a tangent from the center point to that point of contact, right? And it will always makes a right angle. Right? Center point to the point of contact will always makes a right angle with the tangent. Understood? The next property is nothing but very easiest property. The length of tangent, right? The length of tangent. Now we are discussing the length of the tangent. Here here see that PA and PB are the tangent, right? Because the point A is the point of contact with circle and the line, right? So PA and PB are the tangents. Okay, here P is nothing but external point. For the external point, we have already discussed. For an external point to the circle, how many tangents are possible? Two tangents, right? PA and PB, right? Okay, the length of the tangents drawn from an external point to a circle are equal. That means from the external point, from that point we can draw two tangents. The two tangents are equal. The length of the tangent, the two tangents are equal. That is PA is equal to PB. PA is equal to PB, right? PA is equal to PB. Second is nothing but, right, second property is very easy one. What is it? Whenever we are having an external point to the circle, we can draw two tangent. The length of the particular two tangents are equal. The length of the two tangents are equal. That is PA is equal to PB, right? Now I'm just to see, now we are having two tangent. I'm just drawing the radius, right? I'm just drawing the radius OA and OB, right? OA and OB. See, OA is perpendicular to this PA tangent and OB is perpendicular to this PB tangent, right? I'm just showing that the first property, right? So OA and OB are the radius and the PA and PB are the tangents. So we can draw. I'm just marking the angle. OA is perpendicular to PA and OB is perpendicular to PB, right? And second property is something about PA is equal to PB. From an external point, we can draw two tangents. The two tangents are equal, right, for the same circle. So by using this first property, now I am going to prove. We are having one theorem, right? One proof we are going to see. Theorem 1. See, in this chapter we are having I think so 2 or 3 theorems. I don't know exactly, right? But the theorems are very important. We can expect for our public exam, right? Very easy only, right? First you have to understand how we are going to prove that. See the property, the first property. Tangent at any point of a circle is perpendicular to the radius through the point of contact, right? So tangent, AB is nothing but tangent, and what is it? And OP is nothing but radius. What we want to prove that? We want to prove that OP is perpendicular to tangent AB. The radius OP is nothing but perpendicular to tangent AB. That only we want to prove that. So given a circle with the center O, and a tangent AB at a point P of a circle, right? Given to prove, what we want to prove, that OP is perpendicular to AB. OP is perpendicular to AB, right? So how we are going to prove means very simple. Before explaining this theorem, right? How I am going to prove means, see that, just imagine that. See here, I'm just explaining by orally, right? If you are understanding, then it will be very easy, right? Okay, next what I'm going to explain means, right? OP is perpendicular to line AB. That only we want to. So how it will be means very simple, right? See, I'm just drawing the circle with center O, and AB is nothing but tangent, and P is nothing but point of contact, right? And OP is nothing but radius. Right? See, if I'm just drawing a line segment from O to the line AB. I'm just drawing a line segment from the point O to the line AB, right? What are the lines we can draw? We can draw so many lines, right? We can draw so many line segments, right? From the point O to the AB, we can draw so many lines, right? We can draw so many lines, right? Here I'm just giving a name to the points, right? From the point O to the E, F, G, H, I, likewise, right? I'm just drawing the very closer to the point P also. I'm just drawing the line segment closer to the P also. H, I, J, right? I'm just giving the names. Okay, just see why I'm just see we are having so many line segments from the point O to the AB. We are having so many line segments. AE, OE, OF, OG, OP, OJ, OH, OI, and we are having so many line segments, right? Among this line segment, which is very shortest line segment. OE is shortest line segment, or OJ or OH or OP, which is the very shortest line segment. We can draw, what is it? We are having infinite number we can draw, right? We can draw a infinite number from the point O to the line AB, right? There is a possible, right? We can draw infinite number. So among that line segment, which is the very shortest line segment, OP alone, right? OP alone, right? OP is the shortest line, right? Because the remaining all the lines are somewhat slanting, right? Slanting. So it should be the length should be greater than the OP, right? Greater than the OP. Remaining all will be greater only. Somewhat slanting along, somewhat. If I'm just drawn very close to the P, very close to the P, then OP is nothing but OP is the shortest line. OP is the shortest line, and somewhat this will be, what is it? Slanting along, right? It is slanting. The length should be somewhat 0.01 centimeter. It will be greater along, right? So which is the smallest line, and that is nothing but perpendicular line, right? Already we know that property, right? That the shortest distance, right? The shortest distance between the point to the line is nothing but perpendicular distance. That is very important, right? Already we have studied in I think so 8th or 9th, while we are studying the right angle triangle property. That time itself we have studied that shortest distance between the point and the line, right? Shortest distance between the point and the line, the particular line is nothing but perpendicular line. A small example, I'm just marking a point. I'm A, right, and I have drawn the line, right, B and C, right. You can draw, see, from the point A to the line BC, you can draw the line infinite number of lines, right. I'm just drawing the so many lines, right. See, which is the among these lines, right? I have drawn so many lines. Among this line, which is the very shortest line, right? Which is the very shortest line from the point A to the line BC. That line is called a perpendicular line. Understood? Perpendicular distance. That is something but perpendicular distance, right? Perpendicular distance. So that property alone, now I am going to use to prove that this is nothing but perpendicular. That OP is perpendicular to the line AB, right? So construction, what I am doing, just take a point Q, other than P, right, in AB, other than P, take a point Q and join OQ, right. When I am joining the OQ, I got a point R on the circle, right. See, so Q is a point on the tangent AB other than the point of contact P. Now see that Q lies outside the circle, right. Q lies outside the circle. While I am joining the OQ, I got a point on R on the circle, right? On the circle, right? Let OQ intersects the circle at R, right? Let OQ intersects the circle at R. Now see that I'm just comparing that OR is less than the OQ, right? OR, because OR is a part of OQ, right? OQ is bigger, right? OQ is a bigger one compared to the OR, because OR is a part of OQ. So what I am saying, OR less than OQ, because a part is less than the whole part, right? OR is less than OQ. Now already we know that OR is equal to OP. What is OR? Radius. OP? Radius. So OR is equal to OP. OR is equal to OP. By comparing equation 1 and 2, I'm just taking this equation 1 and equation 2. By just comparing equation 1 and 2, by comparing equation 1 and 2, see that instead of OR, shall I put OP? That means, what does it mean? OP is less than OQ. OP is less than OQ. OP is less than OQ. Understood? So the distance, what is the length of OP is less than the length of OQ. If the OP is the shortest distance, right? If the OP is the shortest distance, then we can say that, what is it? OP is perpendicular to the tangent AB. That only. See the words? Thus, OP is the shorter than any other line segment joining O to any point of AB other than P. In other words, OP is the shortest distance between the point O and the line AB. Understood? But the shortest distance between a point and a line is the perpendicular distance. Therefore, OP is perpendicular to AB. Hence it is. Understood the theorem? So this is very important, right? So today homework is nothing but study all the property, right? Only we are having two property around. Thorough the two properties, and moreover, what is meant by secant, what is meant by tangent. That also you can thorough it, right? And number of tangents, right? Based on the point. If the point lies inside the circle, how many tangents are possible? If the points lie on the circle or outside the circle, thorough that, right? And today homework is nothing but study and write this theorem 2 times. Without saying, you have to write, right? And you have to send it to me. Thank you. You will see the sums based on this theorem, this property based on the sums we will see on tomorrow, right? Thank you.